For generations, the night sky was considered silent and empty, a cosmic wilderness rarely disturbed by outsiders. But NASA's hidden report on 3-Ice Atlas has changed everything. In just 3 days, 5 asteroids swept closer than the moon, a new comet was found by an amateur, and the third ever interstellar object hurtled through our solar system. All at once, experts are now torn. Some say it's chance. Others whisper, it's the end of our so-called quiet sky. If space is suddenly this crowded, what are we missing, and how vulnerable are we really? The answer begins where certainty ends. For centuries, astronomers looked up and saw permanence, a sky governed by rules so steady the ancients could set calendars by the stars. The planets moved in their ancient paths, comets flared up only once in a generation, and the space between worlds seemed a buffer zone, not a crossroads. Scientific textbooks described the solar system as a fortress of order, with the sun and its retinue of planets locked in orbits that would outlast empires, even as telescopes grew sharper and surveys more ambitious. The prevailing wisdom held firm. Cosmic visitors were rare, and the odds of a true outsider crossing into our quiet domain were so low, they bordered on myth. This belief shaped not only scientific models, but public imagination. Space was cast as a silent stage, its dangers distant, its drama unfolding on timescales no human would ever witness. Meteor showers were celebrated as harmless spectacles, not warnings. The last major impact event, Tunguska 1908, faded into legend, while the idea of an interstellar object arriving unannounced was reserved for science fiction for generations. Planetary defense was an afterthought, a line item in budgets, not a daily concern. The quiet sky was a given, an axiom as basic as gravity. Confidence in this serenity ran deep. Astronomers catalogued asteroids and comets, with the patience of archivists, recording the slow drift of familiar objects. The catalog grew, but the pattern remained. New discoveries fit the mold, their orbits looping back to the sun, their origins traced to the asteroid belt or the icy Oort cloud. Even the most ambitious sky surveys rarely found surprises. The rare becomes possible, and the possible becomes a question. Yet for most of the modern era, the sky itself seemed to answer with silence. This sense of cosmic stability shaped how we measured risk. The odds of a catastrophic impact were calculated in millions of years, not decades. Plans for planetary defense, when they existed, focused on theoretical threats. The universe beyond our solar system was another country, and its travelers, if they existed, were presumed to pass us by undetected and irrelevant. The concept of a quiet sky was so ingrained that it became invisible, an unspoken reassurance that tomorrow would look like today. But beneath this veneer of certainty, the tools for watching the sky were changing. Automated telescopes began scanning the heavens every night, sifting through millions of digital images for the faintest hint of motion. Each new generation of detectors saw deeper, faster, and wider than the last. And as the data piled up, the old myth of a serene, empty cosmos began to look less like a fact and more like a comforting story. The silence between discoveries was the rule until it wasn't. Most years, not a single confirmed interstellar visitor is detected. The silence between these discoveries has been the rule, not the exception. When 1I MUA swept through the inner solar system in October 2017, it appended centuries of theory in a single pass. Its trajectory, hyperbolica, one-way ticket from the dark beyond the sun, left astronomers stunned. Oumuamua was small, less than 200 meters long, and showed no trace of a comet's familiar tail. Instead, it tumbled end over end, reflecting sunlight in odd, unpredictable flashes. Spectrographs revealed a surface neither icy nor rocky, but something in between, coated in a reddish haze. No gas, no dust, no easy explanation. The object's speed, over 26 kilometers per second relative to the sun, confirmed it would never return. The debate that followed was as fierce as it was brief. Some called Oumuamua a fragment of a shattered planet. Others speculated about alien technology, but the data were limited, the encounter fleeting, and the object vanished into the night, leaving more questions than answers. For 2 years, the sky returned to its old quiet. Then, in August 2019, a Ukrainian amateur turned up a new anomaly. 2I Boris, the first interstellar comet ever seen. Unlike its predecessor, Boris looked familiar, icy dust pour with a faint blue coma streaming behind it. Its composition matched comets from our own Oort cloud, but its speed and angle of approach told a different story. Boris was not from here. It had traveled for millions of years across the void, carrying the chemistry of another star system. The odds of witnessing even one interstellar object in a lifetime had seemed remote. To find two in less than 3 years forced a reckoning. Astronomers recalculated the odds, revised their models, and wondered aloud what else might be passing through unseen. The Minor Planet Center assigned these objects a new naming convention, numerals for their order of discovery, a mark of how extraordinary they were. 1 I per astronomical unit, Imue, 2 I Boris. Each one a singular event, a cosmic outlier. Yet the sense of astonishment lingered. Both discoveries arrived unannounced, detected only because new survey telescopes were watching more of the sky, more often. The possibility of a third interstellar visitor seemed almost outlandish. A scenario for future generations, not the present. The rare became possible, and the possible became a question. What else might be moving through the darkness, waiting to be found? The next detection would not just surprise astronomers, it would force them to confront whether the sky's quiet was ever real at all. In the first week of August 2025, 5 asteroids swept past Earth in just 3 days, each one crossing inside the Moon's orbit. The smallest, no wider than a city bus, was first flagged by a survey telescope in Arizona. Within hours, NASA's Planetary Defense Coordination Office began round-the-clock calls with observatories worldwide. The official threshold for a lunar close pass is 384 kilometers, yet all 5 objects crossed that line, and one slipped by at less than 100,000 kilometers, barely a quarter of the way to the Moon. The tracking window for these visitors rarely stretched beyond 72 hours. Analysts at JPL and NASA recalculated orbits in real time, debating whether to issue public alerts. Some argued for immediate notification, pointing to the object's proximity. Others urged restraint, citing the small size and low probability of impact. But tension was not just technical. Internal logs described a sense of vulnerability, knowing that if any one of these asteroids had been on a different trajectory, warning time would have been measured in hours, not days. Conference calls ran late into the night. Teams weighed the risks, reviewed new radar data, and checked for signs of fragmentation or unexpected course changes. The official catalog filled with new designations, each one a reminder of how quickly the sky could turn from quiet to crowded. For planetary defense, the episode served as a stress test, exposing both the strengths and the gaps in current surveillance. The rare clustering of these objects forced a reckoning. The old comfort of distance and time had vanished. Now, the question was not whether the sky was safe, but whether anyone could say for sure what was coming next. At 2:13 in the morning, Alexander Ritsenko stepped out onto his small balcony in Kiev, Ukraine, and turned his telescope skyward. The city around him was quiet, but the sky above was restless, alive with possibilities. Ritsenko, an amateur with a passion for faint, uncharted objects, had spent years scanning digital sky maps and chasing rumors of new discoveries. That night, a barely perceptible smudge caught his eye, a ghostly blur where no catalog predicted one. He checked the coordinates, cross-referenced the latest public databases, and realized he might be staring at something entirely new. He snapped a series of images, each one a little clearer than the last, then posted them to an online forum where amateur astronomers gathered to trade discoveries and doubts. The response was instant. Within minutes, messages lit up from Spain, Poland, and Brazil, observers pulling up the same patch of sky, confirming the presence of a diffuse glow hovering at magnitude 8.7. Some used borrowed equipment, others braved clouds or city lights, but the excitement was the same everywhere. This was a comet, and it belonged to no one's list. By dawn, confirmation emails arrived from 2 professional observatories. The object's movement and brightness matched Ritsenko's initial report. In a world dominated by billion-dollar telescopes and automated surveys, a backyard astronomer had found what the machines had missed. Ritsenko described the moment as exhilarating and humbling, a reminder that the universe still rewards patience and curiosity. For the global community of amateurs, it was a victorious celebration of human eyes and human wonder, proving that, even in an age of algorithms, there is still room for discovery under the open sky. On July 1, 2025, a faint object appeared in the nightly data stream from the Atlas telescope in Chile. At first it looked like a routine detection, just another moving point among thousands, but the numbers told a different story. The object's path sliced through the inner solar system at an angle and speed no local comet could match. Early calculations put its velocity at 245,000 kilometers per hour, far beyond the reach of solar gravity. Its orbit was hyperbolic, a one-way ticket from deep space. Within hours, confirmation arrived from observatories around the world. The Minor Planet Center assigned a new designation, 3I Atlas, the third confirmed interstellar visitor in recorded history. The principal investigators on the Atlas team, John Tonry and Larry Deneau, watched the data unfold in real time. They had seen false alarms before, asteroids, data glitches, even satellites masquerading as cosmic newcomers. This time, every check agreed. The object's origin pointed back toward Sagittarius, a region thick with stars, making the discovery all the more unlikely, as astronomers rushed to book time on the world's largest telescopes. The first images revealed a nucleus up to 20 kilometers wide, shrouded in a dense, dusty red coma. Unlike Boris, there was no bright tail, no jets of gas. Unlike Oumuamua, there was no tumbling charge, just a steady, glowing core. Its surface reflected the deep red of ancient cosmic dust. The science community, mobilized at a pace reserved for only the rarest discoveries, spectrographs captured a color slope redder than most local comets, but not as extreme as Burr. The coma showed evidence of CO-driven activity, with dust streaming outward, but no clear sign of water or organics. The object's brightness increased rapidly as it neared the sun, but its outgassing remained subdued, a puzzle for comet researchers. The Atlas team fielded questions from colleagues and the press, each answer only deepening the sense of awe. Here was a fragment of another solar system, older than any human civilization, now passing through ours at impossible speed. The discovery of 3I Atlas did more than add a name to the catalog. It shattered the illusion of a quiet sky, forcing astronomers to confront new questions about what else might be hiding in the darkness, between the stars. Inside the planetary defense community, the sudden swarm of new discoveries has set off a debate that shows no sign of settling. Some scientists look at the numbers, the clustered asteroids, the interstellar comet, the outpouring of amateur finds, and see an unmistakable anomaly. Argued that the odds of so many rare events arriving together are too remote to be dismissed. According to this view, something in the solar system's environment must be changing, even if the cause remains hidden. Others, equally seasoned, point to the relentless march of technology. They note that today's surveys scan wider swaths of sky with sharper sensitivity and faster data pipelines than ever before. For every object missed a decade ago, dozens are now caught in digital nets and flagged for follow-up within hours. What once slipped by unnoticed now triggers global alerts. The debate often plays out in technical meetings and late-night message threads, but the tension is real. One camp warns that statistical models no longer fit the cascade of recent events. They cite historical records showing how past decades rarely saw more than a handful of close approaches or new comets in a single year. The other camp counters with detection curves and survey logs, insisting that the surge is a product of better eyes, not a busier sky. Both sides agree on one point. The pace of discovery has outstripped the ability to explain it. Each fresh detection forces a recalculation not just of trajectories, but of what is possible. In this climate, certainty is scarce, and the meaning of the 2025 surge remains an open question. The sudden acceleration in discoveries has forced a reckoning, not just among scientists but across the global policy landscape. In the aftermath of the August events, international agencies have begun drafting new protocols for data sharing and rapid response. Proposals for a unified planetary defense network linking the Atlas survey, Europe's FlyEye project, and Japan's new wide-field array now circulate in committee rooms from Washington to Geneva. Funding drives have already started, with calls for billions more in investment to expand automated sky patrols and launch next-generation space telescopes. The aim is clear: to close the gaps that let small, fast-moving objects slip through the net. Yet, even as the infrastructure grows, the sense of vulnerability lingers. The NEO Surveyor mission, once promised as the backbone of planetary defense, remains delayed its launch date, slipping further into the future with every budget fight. Scientists warn that the current pace of discovery may still underestimate the true number of threats lurking in the dark. Despite new alliances, the warning from planetary defense experts is blunt. The risk is not what we've seen, it's what we might still be missing. The scientific community, once divided by debate, now faces the same uneasy reality. The sky that seemed so empty for generations is proving to be restless, unpredictable, and full of surprises. Each new object found is a victory for vigilance, but also a reminder of how much remains unseen. The story of 3 Ice Atlas and its multiplying companions is not finished. It is a warning written across the stars. A call for constant watchfulness in a universe that no longer feels quiet or safe. In 2025, 5 asteroids passed closer to Earth than the Moon in just 3 days, while the discovery of 3 Ice Atlas marked only the 3rd confirmed interstellar object in recorded history. These facts, drawn from NASA's official tracking logs and minor planet center bulletins, underscore a dramatic shift from centuries of presumed cosmic quiet to sudden measurable activity. Yet, as the Harris-Faranoia debate shows, experts remain divided. Is this surge a sign of better detection, or a real change in our solar system's environment? NASA's own documents reveal that gaps in planetary defense persist, and delays like those affecting the $1.2 billion NEO Surveyor mission have real consequences. Despite detailed observations, key causes and long-term risks are still unconfirmed. The evidence leaves no doubt. The era of the quiet sky is over. What lies ahead remains uncertain. But the need for vigilance, grounded in the facts, is greater than